Okay, this is a brief set of notes on what we're going to call the uniform distribution. When you have a uniform distribution, basically every single x value or range of x values in the probability distributions domain has an equal probability of occurring. So the graph of this thing basically looks like this. It's like I'm starting at some value in my range. This will be, let's call that like the minimum value of my range. And I have the maximum value in my range. And all the values from the minimum to the maximum, whatever subset of those values I choose. Let's fix that. Having trouble drawing straight lines here. From the minimum to the maximum have an equal probability. So long as they have the same size width, they will get the equal probability. So basically we're going to come up with some number. We're going to call that B, and that is maximum minus minimum, right? And this f of x up here, the value of this is actually going to be that 1 over b. So let's take an example of how this might work with real numbers. Okay, so let's say that we're in a train station, okay? And a train arrives every 5 minutes, okay? So the longest possible time that you would have to wait for a train is 5 minutes. The least amount of time you'd have to wait for a train is 0 minutes, right? So what we have here is that if you came into that train station, you could be coming in at any time between that 0th minute and the 5th minute. And that's an equal probability of occurring. All right, so our minimum value here is 0. Our maximum value here is 5, which means B here is going to be 5 minus 0, right? So that's just 5, right? F of x is going to be 1 over 5, which is 0.2. So the entire reality here is at 0.2. So the shape of my probability density function here is actually just a line, and the space underneath that is going to be a rectangle. So what do I want to know? Like the probability that I would have to wait between two, let's see, so there's 0. Let's kind of be a little more precise about this. Let's see, there's 1, 2, 3, 4, right? So there's 1, 2, 3, 4, 5 minutes, right? So what's the probability that I would have to wait between 2 and 4 minutes? Well, lo and behold, that makes a rectangle. The width of this rectangle is 2. The height of this rectangle is 0.2. So the probability that I would have to wait between 2 and 4 minutes is going to be the area of that rectangle. 0.2 times 2 is 0.4. I'd have a 40% chance of having to wait between 2 and 4 minutes. All right, so there you go. That's the whole deal. Thank you.